This is an answer to question 4 on the S1 paper, January 2013. It's how many different 3-digit numbers can be formed using the digits 1, 2 and 3, and in part A, when no repetitions are allowed. So part A says how many arrangements are there of the numbers 1, 2 and 3? Well, there are 3 of them, so they can be arranged in 3 factorial ways, which is 3 times 2 times 1, which is 6. In part B, it says if repetitions are allowed. Well, if you think you've got 3 digits, the first digit can be any one of those 3. The second digit can also be any one of those 3 because repeats are allowed, and the third one can be any one of those 3. So if I times those together, 3 times 3 times 3, which is 3 cubed, you get 27. And part C is each digit must be included at most twice. So the way I thought of that was, well, you can have all of them except, so that's all 27, except you're not allowed 111 or 222 or 333. So there are 3 out of the 27 that aren't allowed. So the answer to part C is 27, take away those 3 that aren't allowed, which gives you an answer of 24. If we move on to part 2 of the question, it's now talking about 4-digit numbers, and it says how many different 4-digit numbers can be formed using the digits 1, 2 and 3 when each digit may be included at most twice. Well, I thought, well, let's do it the same way as we've done sort of part 1, really. If repeats are allowed as many times as you like, there are 3 ways of having the first digit, 3 for the second digit, 3 ways for the third digit, and 3 choices for the fourth digit. Well, that gives you 3 to the power of 4, which is 81. Now let's work out what's not allowed. We're not allowed to use anything more than twice, so we're certainly not allowed to use things 4 times, of which there are 3 possibilities. So I need to subtract 3 because I'm not allowed to use those. But I'm also not allowed to use things 3 times. So for example, I'm not allowed to have 111 followed by any other number which isn't a 1, or 222 in any number that isn't a 2, or 333 in any number that isn't a 3. I'm thinking, well, okay, how many ways are there of having 111 and then another number which isn't a 1? So it's either got to be 1112 or 1113. So that's 2 ways. And that'll be the same for each of these down here. That can either be 2221 or 2223. But then of those 2 ways, the number that isn't a 1 could be in any of 4 positions. So that 1112 could also have been 1121 or 1211 or 2111. So each of those 2 ways could actually be split into 4 other ways. So there are 8 ways of doing that. Those 2 split up 4 times. And there are then 8 ways of getting the 222 in something else, and 8 ways of getting the 333 in something else. So I found in that section another 24, which is those 3 8s, 24 arrangements that I'm not allowed. So if I start with my 81 and take away 3 and take away 24, I will get the number that I am permitted. And if you do that, you get an answer of 54 arrangements.